AI landscape shifts, competition sharpens. The latest State of AI report paints a sharper competitive map. OpenAI still leads at the frontier, but China has become a credible number two, with DeepSeek, Qwen, and Kimi closing the gap on reasoning and coding. The report also tracks a broader pivot toward agentic systems, models that plan, reflect, and self-correct over longer horizons, and notes that embodied AI is beginning to reason step by step before acting in the physical world. On adoption, the shift from experimentation to enterprise spend is unmistakable. 44% of U.S. businesses now pay for AI tools, average contracts hit $530,000, and a practitioner survey finds 95% using AI at work or home. Compute is the new choke point. Multi-gigawatt data centers backed by sovereign funds signal the industrial era of AI, even as the policy conversation moves from existential risk to reliability and cyber resilience. Safety research has entered a pragmatic phase. Models can imitate alignment under supervision, raising transparency questions, and external safety orgs now operate on budgets smaller than a frontier lab's daily burn. Meanwhile, regulation diverges. The U.S. leans America First AI, Europe's AI Act stumbles, and China expands open-weights ecosystems and domestic silicon ambitions. The net, faster capability progress, wider deployment, and rising pressure to measure and govern what matters. As capabilities broaden, the report's takeaways spotlight a practical reality. Specialization and verifiable reasoning increasingly beat general-purpose hype. That theme runs through the week's launches and papers below, across extraction, efficiency, agents, and security, and underscores why rigorous evaluation and disciplined workflows matter more than ever. Small specialized models surge. Inference.net claims its small schematron models, 3B and 8B, rival frontier systems for one job, extracting strict JSON from messy HTML, while running 10 times faster at 40 to 80 times lower cost. The 8B variant, fine-tuned from Llama 3.1 8B and distilled from a frontier teacher, reportedly scores 4.64 in an LLM as a judge evaluation versus 4.74 for GPT 4.1. The 3B scores 4.41. A 128K window and training to preserve accuracy at the edge aim to keep schema compliance near 100% for long pages. Caveats apply. Claims are task-specific, LLM as a judge is imperfect, and the teacher is unnamed, but the strategy, curate web data, synthesize schemas, distill to small targets, is sound for HTML JSON workloads. Efficiency advances are arriving from multiple angles. On CPUs, Google Cloud's new C4 instances, Intel Xeon 6 Granite Rapids, show 1.4 to 1.7 times higher normalized throughput per vCPU on an open-source mixture of experts, GPT-OSS model, compared to prior Gen C3 Xeon 4th Gen, translating to a similar TCO advantage at parity pricing. An optimization merged into transformers avoids experts processing tokens they weren't routed to, eliminating wasted flops and making CPU inference viable for large MOEs that activate only a subset of parameters per token. On the model side, 2 open releases emphasize long context multimodality and efficient sparsity. Qwen 3 VL8B Instruct brings a native 256K context expandable to 1M, stronger spatial video grounding, upgraded OCR in 32 languages, and visual agent capabilities to operate GUIs and invoke tools, bridging perception and action for agent workflows. Meanwhile, Ring Flash Linear 2.0 combines hybrid linear standard attention with a sparse MOE, 137 expert activation 6.1b active params to hit near linear time and constant space complexity, claiming 40B dense level quality with 128K context and standout throughput for long inputs and outputs. Smarter evaluation, less hype. Choosing evaluation tooling is now as strategic as choosing models. A comparative review highlights trade-offs. Langfuse and Era's Phoenix shine at tracing and observability but need custom evals. BrainTrust supports dataset-centric regression testing. Vellum and Langsmith help with prompts and chains. Comet brings mature experiment tracking. LangWatch adds lightweight monitoring. Maxim AI leans into all-in-one experimentation, evaluation, and observability with automated and human-in-the-loop options, useful for teams wanting fewer stitched-together systems. Why it matters. Model marketing is getting louder. When a small extractor rivals GPT-5, the right question is, on what benchmark, with which judge, and how does it fail? The platforms above help catch regressions in real workloads, not just leaderboard deltas. If results don't replicate across your corpus and schema constraints, the cost curve is academic. The State of AI reports adoption data ups the stakes. With 44% of U.S. businesses paying for AI, evaluation debt turns into production debt fast. Building repeatable dataset-anchored evaluations and wiring them into CI/CD keeps comparable quality. Claims honest and ensures performance doesn't degrade as prompts, tools, and context windows evolve. Local LLMs and home labs. Reports of Allama's demise are exaggerated. A community thread pushes back on claims of a partnership with OpenAI. There isn't one, notes ongoing updates and model releases, and clarifies that Kimi K2 variants run locally are quantized, distilled community conversions, not the full proprietary model, which remains cloud-only due to resource demands. Allama runs GGUF models and can pull from Hugging Face with caveats for multi-file packages. Still, some users have defected to llama.cpp, LM Studio, or VLLM for performance or reliability on certain machines. The ecosystem remains diverse and opinionated. On DIY training, reproducing Karpathy's NanoChat on one GPU is doable with the right trade-offs. A step-by-step Colab notebook on a single A180GB ran smoothly. On smaller GPUs, e.g. RTX 3090, users report lowering device batch size, using gradient accumulation, and enabling mixed precision FP16 BF16 to fit VRAM at the cost of speed and stability tuning, e.g. learning rate. The README suggests single GPU runs will be 8 times slower without torch run. Patience and memory-savvy hyperparameter tweaks are the tax for local experimentation. If building a one box to rule them all, the community advice is conservative. Don't combine gaming and home server roles if you care about reliability. Multi-GPU boxes introduce headaches, power, cooling, PCIe layout, and pre-built options like Mac Studio trade flexibility for unified memory and simplicity, at a premium and with fixed GPUs. GPU procurement is easier than peak scalper years, but custom builds still win on price/perf if you can tolerate the tinkering. Evaluate whether your AI workloads truly need multi-GPU. CPU-friendly MOEs and efficient 8 to 30B models often suffice. Agent frameworks go practical. Claude Code's underlying agent harness is now the Claude Agent SDK, positioned for far more than coding. It standardizes agent outputs as transparent message blocks, text and tool invocations, supports granular permissions, integrates MCP, Model Context Protocol servers, and can be wired to apps like Telegram and Obsidian for live edits with tool usage traces. In one demo, the agent self-modified to add an MCP server from a phone while maintaining explainability and centralized policy control, signals of maturing agent operations, not just chat UX. Vendors are converging on portability. Oracle's Open Agent spec proposes a framework-agnostic, declarative way to define agents and flows, e.g. React or business processes, with SDKs to serialize, deserialize JSON YAML and runtimes that adapt specifications to concrete frameworks. The goal, compose multi-agent systems once and execute across stacks with fewer rewrites. Agent frameworks are proliferating in the NPM ecosystem too. Agentic Flow markets an agent framework that gets smarter and faster every time it runs, and the page doubles as a timely reminder of platform security. NPM token lifetimes and 2FA rules are tightening, with classic tokens slated for revocation. If you're scripting CI agents around package registries, update auth flows now to avoid surprise outages. Coding with multi-model orchestration. Developers already route work across multiple models, and the pain is context transfer. A survey thread describes a common pattern. Use a planner model, e.g. Claude Sonnet 4.5, as an orchestrator, then delegate to specialized agents, e.g. Grok Code Fast for implementation, Gemini for web research. The practical fix for handoffs. Generate a technical spec up front. Tools like OpenCode AI let you define agents, tools, and rules, set per-agent temperatures, and run tasks in parallel. The more the plan is codified, the less brittle the workflow. A complementary mindset, compounding engineering, treats AI systems as assets that learn from every interaction. Teams maintain living artifacts, LLMs.txt, encode preferences and patterns, and wire subagents that write, review, and argue to surface better answers. Results cited include week-long features landing in days and automated code reviews based on months of prior feedback. The caution from practitioners: avoid universal lessons. Compounding works best as project-specific context that grows with each PR. Together, these threads point to a near-term equilibrium. Agentic coding succeeds when plans are explicit, responsibilities are modular, and knowledge accrues locally to the codebase. It's less prompt the one true model, and more design the system that designs the system, with guardrails that make delegation auditable. RAG and memory pragmatics. A new RAG technique from Meta's superintelligence group drew polarized reactions, some decrying influencer-driven hype, others, including a S2E working on RAG, finding it useful. Regardless of the commentary, the paper's existence underscores continuous iteration on retrieval, reasoning, and context management. Link to the paper sits atop the discussion. If you care about production RAG, skip the blog takes and read the method. For agent memory, SQLite is a compelling default. One practitioner outlines storing F32 embeddings as blobs with pre-computed norms, adding small Rust functions for cosine similarity, and leveraging pragmas and map cache for microsecond retrieval. Each agent spins up a local DB, fully in memory for speed or on disk with WAL for persistence, to recall past runs, measure reasoning shifts, and compress older data into memory graphs. Heavy vector DBs have their place, e.g. cross-agent global retrieval, but for local reasoning, reflection, and fast context, SQLite is simple, fast, and self-contained. Taken together, new RAG papers are worth a read, but robust memory often hinges on pragmatic, low-overhead stores and careful curation. Before adding another microservice, ask if a per-agent SQLite plus good chunking and schema discipline gets you under your latency SLO. Trust, verification, and AI. Deloitte Australia's refund over a GenAI-authored report with non-existent citations is a reminder. Verification beats vibes. An editorial reimagines Asimov's laws for today. Models should admit, "I don't know," and IT leaders must not injure their employers by skipping verification. The uncomfortable conclusion: strict verification will reduce the rosy ROI some executives expect. But if validation kills the ROI, perhaps it wasn't real in the first place. Treat AI outputs like off-the-record tips. Use them to guide questions, then do the legwork. The same skepticism applies to analytics. A marketer analyzing 200 e-commerce sites found an average of 73% fake traffic, including bots engineered to mimic quality engagement with uncanny regularities, e.g. constant dwell times, scripted cart behavior. After aggressive filtering, one client saw traffic down 71% but sales up 34%. The piece also distinguishes good bots, e.g. large-scale retail scraping for stock price intelligence, from fraudulent traffic, and notes the platform incentive problem. Filtering out bots would crater ad revenues. Audit spikes versus sales, hunt for two perfect metrics, and trust your domain intuition. As model usage goes mainstream, governance isn't optional. Evaluation platforms reduce model risk, disciplined RAB memory reduces freshness and hallucination risk, and analytics sanity checks reduce marketing waste. The through line: verify first, automate second.
Side channels, deepfakes, access control.
A clever side channel shows how hardware progress creates new attack surfaces. High DPI mice, 20,000 DPI, with high sampling rates, can pick up pad vibrations, enabling malware to reconstruct speech at roughly 60% under ideal conditions or track nearby movement. It's theoretical, requires compromise, and is vulnerable to noise, but peripheral telemetry isn't routinely monitored by security suites. Worth adding to threat models as devices get better. Meanwhile, deepfake voice detection remains an active research front. A new Erixiv preprint argues it's all in the presentation, highlighting that how audio is presented can make or break detectors. The implication for defenders: don't overfit to easy mode inputs. Test across realistic playback recording chains and adversarial conditions. On the defensive side, Thand offers a just-in-time open-source PAM agent that eliminates standing admin access across local systems, cloud IAM, and SaaS. It orchestrates deterministic grant-revoke workflows with temporal.io, keeps ephemeral servers stateless, logs all requests for compliance, and ties access to identity with automatic revocation when users go off task. For orgs rolling out agentic automation, this is the kind of least privilege infrastructure that narrows blast radius. Copy and patch JIT explained. If you enjoy low-level craft, a tutorial on copy and patch shows how to build a baseline JIT without writing assembly. The idea: implement tiny C stencils for each bytecode-like operation, compile them to native fragments, then at JIT time, memspy fragments back-to-back and patch relocation holes for constants and addresses. You get native code in the same ballpark as traditional baseline JIT, with minimal compiler wizardry. The walkthrough compiles stencils with Clang, inspects relocations via objdump, and emits a small JIT engine that concatenates fragments and flips memory permissions, mmap plus mprotect, to execute. A simple example specializes a function at runtime to compute 1 plus 2 by overriding placeholders, illustrating how tiered interpreters can cheaply erase dispatch overhead. Macros make declaring 32 64-bit holes and function pointers ergonomic. Why it matters: as agent frameworks and runtimes multiply, baseline JITs remain a pragmatic path to speed without committing to heavyweight optimizing compilers. Whether you're prototyping a DSL for tool calls or instrumenting agent chains, copy and patch keeps performance wins accessible and maintainable.